Okay, let's look at homework 4.2, 4.3, problem number 13. All right, so we have this function given, f of theta is equal to 2 cosine of theta plus cosine squared of theta, and theta goes from between 0 and 2 pi. All right, so we want to find the interval increase and interval decrease. All right, let's do that. Alright, so we need to find the derivative, so go ahead and take the derivative. So f prime of x is going to be equal to, right, derivative of 2 cosine theta is negative 2 sine theta, right? Then derivative of cosine squared, so it's going to be 2 in front, and keep the cosine of theta, then multiply by derivative of cosine, that'll be negative sine of theta. All right, so we can factor out what's in common. So we can factor out negative 2 sine, so negative 2 sine of theta, right? So we have negative 2 sine of theta here, and there's a negative 2 sine of theta. Right? So what's left is going to be from the first term, it's going to be 1, because we basically factor out the whole thing, and from the second term you have cosine of theta. All right. So we're going to set this equal to 0 to find the critical number, right? So this will give us, right, so we need sine of theta to be 0. And here we want cosine of theta to be negative 1. So cosine of theta to be negative 1. Right? So from here we can see that this is going to be theta is going to be, right, so sine of theta is 0 when theta is 0, and also pi, and maybe 2 pi. So those are endpoints, right? 0 and 2 pi are endpoints. And also you have cosine of theta is negative 1 when theta is pi, right? So let's do a number line. All right, so number line, let's draw a number line here. All right. All right, then it's going from 0, so from 0 to 2 pi. All right, then tick marks would be just pi, which is right in the middle. All right, so let's look at the sign of the derivative. All right. Alright, so we can try anything in between 0 and pi. So we can try pi over 2. So f prime of pi over 2. Right? So if you plug in here, so sine of pi over 2 would be, so it's going to be sine of a pi over 2 is going to be 1. And so this is going to be negative. So here it's negative because of the negative sign. And 1 plus cosine of pi over 2. Cosine of pi over 2 is 0, so it's going to be 1. So that's going to be positive, right? So negative times positive would be negative here, right? So you have this is negative, right? And between pi and 2 pi, so that will be f prime of say like a 3 pi over 2. Right, so if you put 3 pi over 2, so this is going to be sine would be negative 1, So that's going to be positive there, right? And a 1 plus cosine of 3 pi over 2 is going to be actually cosine of 3 pi over 2 is 0 again, but plus 1, so positive. So it's going to be positive here, right? So we know that it's going to be decreasing here. So we know that here f is going to be decreasing on this interval and increasing on this interval, right? So it's going to be between 0 and pi, decreasing, pi and 2 pi, increasing, right? Let's type it in, right? So increasing would be, oops, I forgot, increasing is, okay, pi, right? So this is going to be from pi, and Greek letter, and from pi to 2 pi, right? And interval decrease would be 0 to pi. All right, so let's check the answer. All right, looks like we got part A correctly. All right, so let's do part B, which is finding a local minimum and a local maximum value. All right, so let's do that. All right, so looks like local minimum value or max happens right here. So here is the critical number. And since decreasing turned into increasing, so you would have a local minimum there, right? Then we have to find a corresponding value. So we need to find f of pi, right? So 2 cosine of pi, so 2 cosine of pi plus cosine squared of pi, right? Cosine of pi would be -1, so it's going to be a -2. So 2 times -1 plus -1 squared. So it's a -2 plus 1, so it's -1, right? So that's local minimum. So let's type it in. All right, so local minimum would be -1. Right, then local max does not exist, so we can just say does not exist. All right, so let's check the answer. All right, it came back and looks like we got part B correctly. All right, let's look at part C. So part C, we need to find inflection points and concave upward and concave downward. All right, so let's do that. Right, so in order to find inflection points and discuss concavity, we need a second derivative. So let's find the second derivative. So f double prime of x is equal to, right? So we need to use product rule. So I'm going to leave -2 as in front, and here is the first guy. And this is the second guy, right? So let's take the derivative there, right? So -2 is a constant multiple, right? Then take the derivative of the first guy. Derivative sign is cosine of theta, right? Times the second guy, which is 1 plus cosine of theta, right? Plus first guy is sine of theta. Then multiply by derivative of the second guy, which is going to be a negative sine of theta. All right. Then we just need to simplify a bit. Let's see. So this is going to be, right? So it's -2. All right. So there's going to be a this is going to be a cosine of theta plus cosine squared theta, right? So minus sine of theta, so minus sine squared of theta is going to be plus cosine squared theta minus 1, right? Because sine squared is 1 minus cosine squared, but with the negative sign we change the sign. So you would have something like this, negative 2, right? So combine these two guys together, you have 2 cosine squared of theta plus cosine of theta minus 1, right? So I think we can factor this out. So it's negative 2, right? So you have a 2 cosine theta, and you have a cosine theta. Then you would have a plus 1 here and minus 1 here, right? So then we set this equal to 0, right? So you will see that there are two things we can get. So we want cosine of theta to be 1/2, or we want cosine of theta to be negative 1, right? Cosine of theta is 1/2, which means that let's say 1/2 would be theta is equal to pi over 3, or it's going to go around, so it's going to be 5 pi over 3, right? Between 0 and 2 pi anyway. And then we want cosine to be negative 1, so that would be only way it would be pi, right? So let's do a number line. So do a number line here, right? And it's going from 0 to 2 pi. Right, then we have to put the 3 tick marks, so pi is right in the middle here, and pi over 3 would be somewhere around here, so pi over 3, and then you have a 5 pi over 3 would be somewhere around there, 5 pi over 3, right? Then we just have to look at the sign of f double prime. Right? Try something between pi over 3 at 0 and pi over 3, so we can try f double prime of pi over 6. Right? Between pi over 3 and pi, so we can try f double prime of say 2 pi over 3. Right? Then between pi and 5 pi over 3, so we can try like a 4 pi over 3, right? And between 5 pi over 3 and the 2 pi, we can try something like let's try like 11 pi over 6 or something like that. All right, then let's determine the sign. All right, so here this guy is always negative, so we don't have to worry about that, just always negative. All right, so let's try pi over 6, right? If you put pi over 6 for cosine, so it's going to be square root of 3 over 2 minus 1, which is going to, over 2 times 2. So this is square root of 3 minus 1. Square root of 3 is bigger than 1, so this is positive right here. All right, then you have, say, pi over 6 cosine, it's going to be square root of 3 over 2 plus 1, so that's definitely positive, right? So you will have negative sign here, right? And let's try 2 pi over 3, right? So if you put the 2 pi over 3, so cosine would be cosine of let's see, 2 pi over 3 would be a negative 1/2. So it's going to be 1 minus 1, so it's going to be negative here. So you have a negative sign here. All right. Then you have 2 pi over 3 cosine here. Plus 1 is going to be actually positive. So negative, negative, positive. So it's going to be positive here. All right. And after that, we can try 4 pi over 3. All right. So we look at the sign. All right. If you do a 4 pi over 3. So you're going to have, let's see, 2 times 4 pi over 3 would be negative 1/2 here. So it's going to be negative, right? This is going to be positive. So it's actually positive here, right? Then you have, let's see, so we try 11 pi over 6, right? So if you have 11 pi over 6, here 11 pi over 6, so that means the cosine is going to be square root of 3 over 2 times 2 minus 1, so it's going to be positive here. And this is going to be actually positive here, so it's going to be negative. All right, so we know that it's going to be concave down, so original function f would be concave down on this interval, and a concave up here, and a concave up here, and a concave down here. All right, so concavity change only occurs here. So inflection point would be right here at the pi over 3, and also 5 pi over 3 inflection point. All right, so we need to find the value. So f of pi over 3 would be, right, 2 times, right, cosine of pi over 3 would be 1/2, right, plus 1/2 squared, right? So this is going to be 1 plus 1/4, so it's a 5/4, right? Then if you plug in 5 pi over 3, and cosine value is going to be still the same, so it's actually exactly the same value as before. All right, so let's type it in first. All right, so smaller x value would be, so this was pi over 3, so I have to find pi. All right, pi over 3, comma, 5 over 4. And this was 5 pi over 3, comma, 5 over 4, right? So then also we need to look at the concave up and concave down, right? So concave down on this interval and that interval right there. So let's type it in, right? So concave, actually concave downward would be 0 to pi over 3. All right, and take the union, so sets take the union, right? Then you have a 5 pi, all right, 5 pi over 3 to 2 pi, all right? And here you would have pi over 3, so pi over 3 to pi, and then take the union and the pi to 5 pi over 3. All right, so let's check the answer. All right, I came back and looks like we did all these correctly. All right, that's it. I hope that this was clear.